Hi, my name is Peter, and for Building 410 of Curtin University, my theme is water supply and consumption. As part of the site analysis, rainfall for a 30-year period was observed using data collected from the Bureau of Meteorology. Evaporation was also observed as a significant factor for the design consideration. Yearly rainfall was determined to be 936.8 millimetres, and evaporation for the same period was 2,057.3 millimetres. Before designing for water harvesting, it is important to understand the different classifications of water for effective use and treatment. To effectively design for water supply and consumption, quantitative data is collected, calculated, and compared to create what is referred to as a water balance. The first step is to create a water audit determining the use by occupants and requirements by legislation and also operation. With the available floor plans for Building 410 and the intended use in accordance with Section D1.13, page 135 of the NCC, it was determined that 1,281 occupants would use this building. Plumbing fixings were also audited at this stage. Secondly, the catchment area was determined by modelling the building to determine the roof area. 11.2 kilolitres is the water supply from rainfall catchment. This was broken down into monthly observations to determine seasonal supply. Step 3 calculates the demand based on the Curtin academic calendar. We were able to compare seasonal use to seasonal supply. We can see shortfalls and surpluses, where the surpluses water might be stored adequately to supply the shortfall periods. Looking at the water balance for Building 410, the annual supply outweighs annual usage, but the seasonal comparison is where the shortfalls may need to be addressed with adequate storage. Two precedent buildings looked at for alternative water supply were both similar in recycling all water usage, including black water on-site treatment. 1 Bly Street recycles all water and harvests water from the Bondi Ocean outfall to recirculate treated water through the building with separate colour-coded plumbing system. The separate system prevents cross-contamination and supplies toilet flushes, cooling towers and plant irrigation. 1 Central Plaza, using a similar technique, recycles a significant amount of water, being a residential tower, and along with treating recycled and mined water from outside, it provides enough treated water to supply the surrounding buildings. To look at increasing the water supply, firstly, the idea of increasing the catchment area was explored. By covering the adjacent car park and courtyard areas, we would be able to catch a larger area of water from the rainfall. However, based on similar calculations mentioned earlier, it was determined that this might not be a significant solution and would not achieve water balance. Working with Scott Izzard on building integrated greenery and Theodore Lee on energy conservation, it would be a requirement to supply additional water for the recommended systems, and this may affect the water balance which was observed for the existing building. Scott Izzard made recommendations for green walls and planter box shelves to enhance thermal comfort and improve internal lighting conditions. Based on modelling, the green system would require 7.3 kilolitres of water annually. The green wall system also assists to slow down water runoff and capture water on the shelves, which would normally have hit the walls and fallen away to become stormwater. Theodore Lee recommends using a chilled beam system for controlling thermal comfort within the building. And based on modelling, this system would circulate 4.5 kilolitres of water during its operation. However, the water evacuated from the operation of the system could still be used within the building. Also looking at acoustics for the redesign recommendation, it was identified that the basis of the existing plumbing runs up and down through the central core of stacked services in the building, which would be acoustically protected by high mass material concrete. The requirement for resilient fixings on pipes could be minimised this way, and it is recommended that the redesigned plumbing system followed the same method. As per the precedent buildings, it is recommended that the additional water be sourced from the surrounding precinct buildings and possibly from any sewerage running locally through the area, to be treated on-site for reuse within the building. Just looking at the immediate location, buildings such as the School of Physiology, Occupational Therapy, Public Health and Curtin's business schools may provide an additional 40 kilolitres of water annually, and the seasonal supply would more closely match the seasonal demand. Along with meeting the demands for water within the building, and also the requirements for water for the group members' recommendations, this suggested strategy would also create a surplus of water that could be supplied to buildings in the surrounding precinct. Thank you.